In this lesson, we're going to go over Newton's three principal laws, using examples with carts and physics textbooks. We would like to assure you that no humans, carts, or physics textbooks were harmed during the making of this video. Newton's first law is the law of inertia. Inertia basically means that an object in rest will stay in rest, or an object in motion will stay in motion, unless it is acted upon by an outside force.
An outside force can be many things, including pushing, pulling, and friction. Here's a demonstration.
For this first example, we're going to put textbooks on a cart. We're going to roll the cart and then stop it abruptly and see what happens. In this example, we see that when the cart is stopped, the books fall off.
This is because an outside force is directly applied to the cart. However, there is no outside force directly applied to the book. Without a force acting on the book to stop it from moving, the book continues without the cart. This is why it falls off.
The reason the book eventually stops moving is because the force of gravity acts upon it and brings it to the floor. Then the force of friction between the floor and the book slows it to a stop.
Newton's second law has to do with the equation for force, which is force equals mass times acceleration. This shows that as the mass or acceleration increases, so does the force. They are directly proportional with the force.
This also means that if you are keeping the force the same, as the mass goes up, the acceleration will go down, and vice versa. This means that the mass and the acceleration are indirectly proportional. Let's try an example comparing a cart with books on it and a cart without.
Here we see that each cart is pushed with approximately the same force. However, the one with no books on it accelerates faster and therefore hits the wall first. This is because it takes less force to move an object with less mass. Newton's third law is this: every action receives an opposite and equal reaction. The simplest example of this would be that when the book sits on the cart, it doesn't fall through it. This is because when the book applies force to the cart pushes back. However, we think that this example isn't quite fun enough.
Let's try running two carts with the same mass into each other. We see that when the carts collide, they both move back. This is because the carts reciprocate the force that is applied to them. Thanks so much for watching.
Are